Hi, Assalamualaikum. Today we will present about the comparison of Schottky diode and PN Junction diode. My name is Elaine Nazira binti Ahmad Farid and my matrix number is 189819.
Hi, my name is Nur Shafika binti Zulkifli and my metric number is 190124.
Hi, my name is Izzatul Hauzan binti Azmi. My matrix number is 188037.
Hi doctor, my name is Nur Rafika Izzati binti Tan Bici. My matrix number is 190868. So shall we start?
Yes.
Today I want to talk about PN Junction diode. PN Junction diode. What is PN Junction? PN diode is a type of semiconductor diode based upon the PN junction. The diode conducts current in only one direction. PN junction have two terminals electrodes semiconductor devices, which is P-type and N-type. It made from semiconductor materials, and then in P-type semiconductor, the majority of carrier is holes and the minority of the carrier is electrons, while in N-type semiconductor, the majority carrier is electrons and the minority carrier are holes. And then PN diode also have two characteristics, which is forward bias and reverse bias. Forward bias is used in power supply devices and reverse bias used as switch. Okay, this is PN junction, P-type and N-type, and then this is the forward bias and reverse bias. Forward bias is when voltage is applied across the diode and the diode allows the current it is called forward bias. And then the reverse bias is when the voltage is applied across the diode and the diode do not allow the current to flow, so it will call reverse bias. Okay, next I want to talk about comparison between Schottky diode and PN junction diode. Okay, firstly, the formation of junction. In Schottky diode, the junction is formed between the N-type semiconductor to the metal plate. This is the picture where is N-type semiconductor will attach to the metal plate in Schottky diode. And then in PN junction diode, junction is formed between P and type semiconductor, like the picture shown below. And next, the movement of the current. In Schottky diode, the current is a unipolar device, and then the current conduction is happening due to movement of electrons only. And then in PN junction diode, it is a bipolar device. The current conduction is due to the movement of both holes and electron. So that is the difference.
Schottky diode. Schottky diode is a metal semiconductor junction diode. It has less forward voltage drop. When sufficient forward voltage is applied, a current flows in the forward direction. A silicon diode has a typical forward voltage of 600 to 700 millivolts, while the Schottky's forward voltage is 150 until 450 millivolts. This lower forward voltage requirement allows higher switching speeds and better system efficiency. The Schottky diode is named after German physicist Walter H. Schottky and is also known as hot carrier diode. It is a semiconductor diode formed by the junction of a semiconductor with a metal titanium or platinum replace the P-type semiconductor. Moving on to the comparison between Schottky diode and PN junction diode in terms of the forward voltage drops. As compared to PN junction diode, Schottky diode has low forward voltage drop as mentioned. The Schottky barrier diode has electrons as majority carriers on both sides of the junction, so it is a unipolar device. Thus, there is no depletion layer formed near the junction. It gives very less voltage drop across the junction. Next is in terms of the reverse recovery time. Schottky diode has shorter reverse recovery time and the reverse recovery loss as compared to the PN junction diode. This is because the Schottky diode is a unipolar device. This means that no holes movement in the opposite direction. It does not have much reverse leakage current. The current that flows from cathode to anode during reverse bias condition. Thus, there is less delay will happen during electron-hole recombination. Hence, Schottky diode can switch on or off faster than PN junction diode.
So my part is want to explain about the example which to compare the forward bias value when the current have a same value, which is the value forward bias for PN junction at here and the Schottky diode PN diode at here and Schottky diode at here in the same current. So we see the example first. So example, give the form Schottky barrier from platinum silicide on N silicon has a doping density 10 to the power of 16 and area 10 to the power of -3, and a PN diode for PN diode has same area, which is Na equals to density is for acceptor and A equals to 10 to the power of 19 and D equals to 10 to the power of 16, and time constant at holes and electrons equals to 1 microsecond. So for the first questions, ask to calculate the Schottky diode current at the forward bias of 0.4 volt at 300k, which is the current forward bias at here for the Schottky. So at here we want to calculate. So this is a table that we get from page 328. We got the height, barrier height for the certain metals that have calculated and provided. So we see at the questions, we use a silicon and type and the form of platinum silicide. The value of barrier height is 0.85 electron volt. So for find the value we need to find the IS first. IS is the reverse bias. So the equation we get is from page 336. ART square exponent negative Q barrier height over KT. So this calculation. After that, we need to calculate, we need to know the current in forward bias, which we want to find lah. So I equals to this equation, and then when we calculate, we get the 0.27 milliampere. So this IS, we put it in this equation, and then we can calculate the loss. So we move to the next questions, is to determine the value of forward bias. Such I will just show you the graph before. So they need to know the value of forward bias or voltage that deliver the same current with the Schottky diode, which is a 0.28 milliampere. So first we need to calculate our mobility at holes. So this equation we can get from page 93, and then we use equation 4.30 from page 120 to get the calculate the diffusion constant of holes. This is the equations, and then we need to find the diffusion length for holes. This particular elements we need to input on our equations. Before that, we need to calculate also their IS and this one. So after we get the element, the particular element, so we can input on these equations. So we can get, which is Vs equals to 0.64. Let I show you here. So so here is 0.64 volt. So here is 0.4 volt that we find before. So and then here is 0.28 ampere. So that's all from me. Thank you.
Hi, I am Afika and I will proceed our presentation on the characteristic of Schottky barrier diode. As shown on the figure, the PN diode are as in the red color while the Schottky are in the blue color. So, the characteristic of Schottky barrier diode is similar to PN junction, except first, the forward voltage drop of Schottky barrier diode is low compared to PN junction diode. The forward voltage drop of Schottky barrier diode made of silicon exhibits a forward voltage drop of 0.3 volts to 0.5 volts. Second, the forward voltage drop increases by the increasing doping concentration of N-type semiconductor. Third, the Vx characteristic of Schottky barrier diode is steeper compared to PN junction due to high concentration of current carriers. Thank you. Okay, now let's move on to the application. The application of Schottky diode is, it is used in switching power supplies. As it generates less noise, it will use in sensitive communication receivers like radars. It is used in clipping and clamping circuits in computer gating, and it is used in construction of integrated circuits designed for high-speed digital logic application. Okay, now let's move on to PN junction application. There are rectifiers, switch, Zener diodes, and LED. Rectifiers have few examples such as half wave, full wave, and bridge. switch, when the diode is forward biased, the switch is closed and there is current flow. It is vice versa with the reverse bias. The switch will open and there is no current flow. Zener diode is PN junction in reverse bias configuration. For example, digital camera that capture light and produce image. LED is light emitting the diodes. It forward bias produce light when biased with a current. So let's move on to the next topic.